Hello everyone, welcome to my channel Mondal Tech. Today in this video we are going to learn about how to design a XOR gate using Structural Modeling VHDL Language in Xilinx software. So for that, without wasting time, let's get started. So first, we need the basic structures of the circuit to be designed, defining all the signals, input and the output ports. Here is the circuit diagram of the XOR gate that are designed using the basic gates, respectively NOT gate, AND gate and the OR gate, and the total numbers of gates that are used in the circuit is 5, that is 2 NOT gate, 2 AND gate and 1 OR gate. And here you can see the signal S1, S2, S3 and S4 are used also. Now, to design the circuit using structural modeling, we need to follow the following 6 steps. The first step is the defining all the components, that is the basic gates that are used to design the circuit. So that are the AND gate, NOT gate and the OR gate. These are the components, that is we have to see the only type of the components that are used, not the number of components. Now second part is the entity declaration of the main circuit. The second part is the entity declarations of the main circuit. This is the main circuit and we have to declare all the entities. And actually what is the entity mean? The entity represents the external view and specifies all the input and the outputs that are used in the main circuit. That is, this is the main circuit and here we have used A and B as inputs and Y as outputs. This is the entity declaration part of the main circuit. Just we have to see the external view of the circuit, not the internal view. And the next is the architecture definition. So in the architecture definition, we have to define all the components, that is all the basic gates that are used to design the circuit. This is the architecture definition. And after architecture definition is complete, we have to declare all the components that are used in the circuit. We have to declare the components. We have to we define the components earlier, but now we have to declare the components. Then number 5 step is the signal declaration. Here we used signal as S1, S2, S3 and S4. Now we have to declare this signal after components declaration, and after the signal declaration is complete, we have to map the port that are used for each components. So now just open the Xilinx software and we are going to code now. So first create a new project. I am creating, give the name, I am giving as XOR underscore struct struct XOR struct. This is the name I am giving. You can give anything. Next, here you can, don't forget to select the VHDL here. Okay, VHDL. Next, just next, finish. Wait a little. Now here in the diagram you see the components. We have to define the component first. So here there are NOT component here. So we have to first define the NOT component. So here you just project, go to project, new source, and here select the VHDL module and give a module name. Since I am defining the NOT gate, so I will give the name as NOT 11 and don't forget to select this add to project. Next, and here give the input and the output. NOT gate, here input I am giving A and the output is Y, so give it as out. Next, and here finish. Okay, just delete all these unwanted comments section. here this is the entity declaration, this is the architecture of the behavioral model, not 1 So here after begin, you just, the expression is a, input is a y. What should be the output? Output is less than equal to, that is y gets not a, matlab y gets not a. This is the not get declaration. So just save the project and check for syntax, check syntax. Here you can see the process check syntax. The process check syntax completed successfully. So that means the code is fine, perfect. So now again for the now define the AND gate. So for the definition of the AND gate, we'll add another new source, select the VHDL module, give the file name, I am giving it as AND21, AND21. Next, and give the ports input A, B and Y. I am giving the inputs as A and B, and Y is output. So and next, finish. Here this is the AND gate, so Y gets A and B, since A and B are the inputs, A and B. This is the, save the project and check the syntax. Yes, it is done. Now again see the design, and here we have to define another gate, that is the OR gate. So to do that, again add a new source, select the VHDL module and give the file name. I am giving it as core21. Next, and give the input as A and B and output as Y. Select it as out. Next, finish. Remove the unwanted comments, and here this is the OR gate. So here we have to, let's say Y gets A or B. Save the project and compile the code. Yes, it's compiled successfully. Now here we have defined all the basic 3 gates that are used to design the circuit using dataflow modeling. But now we will use these 3 dataflow modeling of these and basic gates to design the structural modeling of the circuit. So for that we will write the code for the main circuit with inputs A, B and the output Y. So this is the main circuit, and we have to write the code for this main circuit with including all the components that we have defined. So now go to Xilinx software again, and here again go to project and add a new source, select VHDL module and give a name. I am giving it as XOR_21. Okay, now next, here the inputs. What are the inputs of the main circuit? A, these 2 are the inputs A, B and output is Y. So we have to define this. A is input, B is input and Y is output. Now click on next, finish. Just remove the unwanted comments line. Okay, now here is, this is the entity declaration. Inside the entity we have defined the the basic skeleton of the circuit, that is the basic structure, A, B as input and Y as output. Now inside this is the architecture. Here I have told you before that inside the architecture we have to design the component, we have to declare the components and the signal. That is, the architecture is used for defining all the internal components that are used to make that circuit. So here I will write here the component first, the NOT component. We have to declare the components. So here just go to the NOT and I am just copying down these 3 lines. Ctrl C, and here I will paste it. So just cut this entity and here write the component not 1 is here and component. Here this is the component of the NOT gate. Similarly we have to declare the component for AND gate. So again copy this and Ctrl V. Here you have to make sure that the component name, this is AND, and these names of the AND gate should be same, and the A, B and Y also should be same. The input and the output variable should also be the same. So here just I am declaring component and for OR gate also. For OR 21 and component. Okay, now all the declaration of the component is done. Now we have to declare the signals. What are the signal we have used here is S1, S2, S3 and S4. So we have to declare this signal. Keyword signal is used to declare the signal. Signal S1, S2, S3, S4 semicolon. Here the standard underscore logic, and the signal is defined. Now the next step is what? Port mapping. Now we have to map the port. So here inside, and this will be inside the begin and the end, inside the begin and the end variable. So here you just write for we have defined here for gate 1. Now we have to make sure the numbers of gates, and according to the number of gates used we have to make the port map. So here the gate total number of gate is 5. So first one is U1. We'll port map for U1. So for U1 it will be as U1 colon. Now we have to, what is the gate type? This is the NOT gate. So we have to use the NOT gate. NOT 11. This is the name of the, we have component not 11, and we have to use the port map. And you see inside the port map what we have to pass. We have to pass, you see here, input and the output. This is the U1, this is the NOT gate, and this is named as U1. And what is the input of this gate is A and the output is S1. So write input, first is the input A, comma the output S1. And similarly for U2, this is the U2. Again this is a NOT gate, so U2. Again here you see the input is B and the output is S2. Here we have write output is S2. So similarly U2 colon NOT 11 port map. here the input is B and the output is S2 according to the diagram. Input is B and output. Now the U3, this is the U3, this is the AND gate. So again I am copying this AND gate U3, make it U3, and here it will be AND gate and 2 1 port map. You see here the input is U3, input is S1 B and the output is S3. So make it input is S1 comma B. These two are the inputs and comma output S3. U4 here and to enter port map. You see for the U4, this is the U4. What are the inputs? A and S2 and the output is S4. So A S2 and S4. S2 and output is S4. And similarly U5. U5 is the OR gate, OR 2 1 port map. Here you see this is the OR U5 and the input is S3 S4 and the output is Y. S3 comma S4 and the output is Y. Okay, and here one thing is noticeable, that here I have taken U1, U2, U3, U4, U5, but you can take this as anything. This is just the name. So you can define anything. You can write anything instead of U1, U2, U3, U4, U5. So this is the complete. Now we have to save it. So just save it and now compile the program. Yes, you can see completed successfully. Compilation completed successfully. So now you can see the RTL schematic. So view it and you will get the basic structure that we have designed similar to that. So this is the external view. This is the external view, that is the entity view. But if you double click it, you can see this is the internal view. That is here this is the NOT here this is the NOT gate, this is the NOT gate, this is the, you can see here this is the AND gate, this is AND gate and this is OR gate. So you can double click it also to see whether it is OR gate or not. So this is the OR gate, you can see this is OR gate and these two are AND gate. Okay, so this is the internal structure of the circuit. Here in the left side you can see that XOR 21, this is the main circuit, and all the U1, U2, U3, U4, U5, these are the components that are used to make this circuit. So you can see here this is the main circuit, and inside this circuit there are components, 5 components, U1, U2, U3, U4 and U5. You can see here U1 and U2 are NOT gate, U3 and U4 are AND gate and U5 is OR gate. So now we can test the circuit whether it is giving the similar output as the XOR gate to travel or not by using test bench waveform. So for that, go to project, add a new source and now select the test bench waveform and give a name. I am giving it as XOR TV. Now make sure that this is add to project is select. Now click on next. Here select the XOR 21. This is the main circuit, not this component. So you have to make you have to select this one. So select this and click on next and finish. Now select the combinatorial or internal clock and click finish. Now set the values for AB inputs. So 0 0 0 1 1 0 1 1, again 0 0 0 1 1 0 and 1 1. Now save this. Now go to process and select here the behavioral simulation. Now here go to Xilinx ISE simulator and simulate behavioral model. So double click on it and wait for a little. Here you can see the input when A and B is 0 0, the output is 0. This is true. When input is 0 1, A is 0, B is 1, then output is 1. This is also correct. And when A equal to 1, B equal to 0, the Y is 1. This is correct. And you can see the final is when A equal to 1, B equal to 1, then the output is 0, which is similar to the XOR gate truth table. And using the waveform, we have seen that the circuit we have designed using structural modeling is correct. Thank you for watching the video. If you like the video, then give a thumbs up, comments below and share the video. And if you are new to my channel, then do subscribe it and press the bell icon for getting updates of my new videos.